Very good afternoon to one and all connected here. I am Pritika Murugeshan, and on behalf of Center for Green Technology, I am greatly pleased to welcome you all to the fifth edition of Innovative Practices of Green Technology, organized by the Center for Green Technology, Institute of Chemical Technology ICT, Mumbai, under the leadership of Professor Aniruddha B. Pandit, Vice Chancellor, Institute of Chemical Technology, and Professor Prakash D. Vaidya, Coordinator of Green Technology, Institute of Chemical Technology, ICT. Today, Team IPGT takes immense pleasure and privilege to witness the presence of our esteemed guests, Mr. Sharad Kalghatgi and Ms. Anagha Barde at our webinar. Good afternoon, one and all. Starting with the session, Innovative Practices of Green Technology, IPGT, is an initiative to inculcate the importance of sustainable and green practices in industrial processes. It is an initiative taken by the Center for Green Technology at the Institute of Chemical Technology, which is a student run organization and aims to provide a platform for the exchange of technical views and information from industrialists, academia, and the students in the domains of green technology and sustainability. Without any further ado, we will now start our session with the introduction of Ms. Anagha Barde. Anagha Barde has completed her MTech Pharmaceutical Technology from ICT Mumbai 2015 to 2017 batch. She is working as a lead data analytics in corporate EHS Cipla. She has previously worked in process engineering, process safety engineering, and technology transfer departments. At Cipla Corporate, she is working on sustainability data management and evaluation. Cipla is focusing on renewable energy usage, CO2 positive, water positive, and zero waste to landfill technology. Along with sustainability, Cipla's aim is to achieve zero harm by providing a safe culture at Cipla. Welcome, ma'am. For today's session, Ms. Anagha will be delivering a talk on sustainability data analytics. It is indeed a great pleasure to witness your presence at IPGT. Ma'am, you may please start your talk.
Thank you so much for such a warm introduction. Hello, everyone. I am Anagha Barde. As she already gave my introduction, but I will give a brief introduction. I have completed my BTech from UD City Aurangabad and my Masters from ICT Mumbai. So ICT is my alma mater, and I'm glad that I got opportunity to give a presentation. I would like to thank Sharad as well and whole ICT Green Technology team. This is a big pleasure for me, and I would like Sharad to share the screen. So I will start my presentation. Hello, am I audible?
Yes, ma'am.
Yeah, okay. So we'll start sustainability data analytics. Uh, as I said, I was joined as a process safety engineer in Cipla in November 19. 3 months back, I joined Cipla Corporate as a data analyst, and I'm working in under EHS department as a deputy manager. So Sharad, can you please take next slide? Yeah, thank you. So this is my short introduction. Next slide. Yeah. So firstly, I would like to talk about Cipla. So Cipla, we have total 46 manufacturing sites around the world, produces 50 plus dosage form and around 1,500 plus products using cutting edge technology platform to cater around 80 plus market. So everybody is known about the brand Cipla, and I am very grateful to be as a part of Cipla. We have API sites at Patalganga, Kurkum, Virgo Nagar, and Bomsandra sites, and formulation sites are in India, are located in Goa, Kundam, Indore, Baddi, Sikkim, Satara. and we do have our overseas site at USA, South Africa, Midian, as well as Uganda. I'm giving this information because the data analytics is nothing but the collection of data. So I'm just giving, as Cipla is having this many sites and everything. So collection of data is starting from here, and as this Cipla is ranked third largest pharma in India, third largest in pharma in private market in South Africa, and is among the most dispensed generic players in US market. So as there are 46 manufacturing sites, so as a Cipla, the tagline for Cipla is caring for life, and we are there to care each and every individual in a manufacturing site as well as outside manufacturing site. So this is our motto, and we are going to give our best. So moving towards my department, that is EHS department. It is nothing but the environment, health, and safety. So first of all, what is environment? So why we are focusing on that EHS? This three different are there. So I will say this as a responsible citizen of India, it is our contribution. Our contribution should be there for this environment. In Cipla, we are giving medications and drugs to like everyone to give a healthy life to each and every individual. But similarly, uh, it is our responsibility to make our environment clean, and it is the I like our today's session is on the sustainability. So how Cipla is contributing in that also we'll talk. The second thing is health. So Cipla is I'm taking like what we are doing at Cipla. So health is our
Did we lose Anagha? Or is
hello.
everyone
Am I
audible?
audible?
Yes, Anagha, you're back. Go ahead.
Ma'am, you were not
Am
audible
I
for the
audible?
past 5 to 3 minutes.
Yeah, you were not audible after you talked about health. So go ahead,
Okay,
Anagha.
okay, okay. I think that. Okay, thank you so much, Sharad. So about health, we I was talking. So Cipla is focusing on health as well. Environment, the health of each individual. In Cipla, we are doing CSR activities. So the company employees as well as the villages, those are nearer to Cipla. We are focusing on that also to give them school education. Like in there are children in school, so we are trying to give them education on safety as well as providing them like a better life and whatever the benefits are there. So we are trying to give our best. In case of safety, I will talk that incident which is like common in all the industries. We are hearing in on newspaper as well as news channel that incidents are there. So each industry is focusing on the safety, and for Cipla, safety comes first. So Cipla is our goal is zero harm, 100% compliance, water positive, carbon positive, and zero waste to landfill. As a EHS, we care about our product, we care about our employee, and we care about our society. So we are trying to give our best in that. Next slide, Shara.
I've put it to the next slide, Anagha. Can you see it?
Thank you so much.
Anagha, we cannot.
So what is data analytics?
Yeah. Go ahead. Keep going, Anagha.
So yeah, please. Yes, yes. Again, click it. Hello.
Yep, Anagha. I can hear you now. Please keep going.
Can you click again? Yeah. So yes, yes. So what is data analytics? So data analytics is nothing but the collection of data. First of all, I gave a introduction about SIPLA, which is we have 46 manufacturing sites, and we have 1,500 plus products. Yes. Hello. Yeah. So we have I gave a brief introduction about the SIPLA, that we have total 46 manufacturing sites. So it is because of the data analytics is start we are getting. Each site we have different units, and the data which we are getting, like I am talking about EHS department. So it is very important to the collection of data. So we as a SIPLA, we are doing the collection of data at per day, like every day, every month, every year, and we action of it is very important that whatever data you are getting raw form, you have to analyze it and interpret it and present it in a proper way, that so the society will understand.
I think Anagha has a very patchy network, so let me take it up till Anagha comes back. Okay, everyone. Now, what is data analytics? Uh, don't go by the word analytics. Okay, analytics is just one aspect of the whole spectrum, and what you see is that it's a science. It's a precious science, and what does it entail? What is collection of data? In the old days, there used to be things written on a book, and then as we advanced, we went on to Excel. Today, the machines pick it up for us. Let me give you an example. That imagine you have a very nice line where initially there is a active pharmaceutical ingredient, and you want to make a tablet out of it in the end. So the active pharmaceutical ingredient comes into a vessel, and then you have excipients and you have other uh, pieces of chemicals that come together. You mix them. You have various unit operations. Mixing is one of them. The other part is, once the mixing is occurred, then there is compaction, then there is packaging. I'm just giving a very generic view. And then once the packaging occurs, the set of tablets, say for example, or the set of strips in a tablets gets collated, and then you have it going into a warehouse. What is happening in the process is the machines are picking up data. Okay, there are certain machines which are running overdrive, and then there are certain machines which are not performing efficiently. What happens from an environment health safety viewpoint is, in the environment part, that is the equipment sustainability part, we pick up which machines are performing efficiently and which are not. And this data is real time. That data gets logged onto a system, and it sits and parks itself somewhere in a system. The next part of which is the which is again a machine learning, is this data is taken by the machine which is there parked at some place, is taken by a random program, and it gives out a set of interpretations and says that this is how I look at it. And that is where a person, we cannot replace, sorry, I'll put it the other way around. A machine cannot replace a human mind. So what happens is, people like us, we pick it up and we start looking at which of these machines we can do a histogram, history matching. We can do a lot of analysis to say how efficient is this process, what are the bottlenecks, how can we make the process better, and if we are able to marginally slow the speed of the line or increase the speed of packaging, are we becoming more productive, and are we importantly consuming less energy because of this? All that helps us. So this, just one small example, is what helps us to know what is data analytics. Similarly, there is information all around us. Like there are incidents, accidents, near misses, even so what I talked about are lag indicators in a safety world. The lead indicators are there are concepts, there are tools like behavioral observation system or behavior based safety. There are various technologies, like in the COVID world, we know that people track and trace can occur. All this is tremendous amount of data that gets logged in. And what we at the back end can do is analyze this data and evaluate as human beings, what can we learn from this and how can we get better. The whole science, the whole purpose behind the data science, the purpose behind it is to get better. What I was yesterday, am I making it efficiently, that is efficient in terms of environmental emissions, and am I making it more safely? And the third part, which is equally important, is our people caring for life, right? That's what Anagha was saying is our credo at Cipla. So what we can do is we can see if there are any injuries, may not happen today, but may happen 5 years from now. Why? Because, for example, someone is lifting and keeping a box every day. It's a repetitive activity. Or someone is hearing a noise every day. That's a white noise. So we can predict the future to say that this is not right. What can we do in terms of improving their health, occupational health? So this is the way we can get better at getting better. Okay, Anagha, I see you are back online. You want to continue talking? I just explained our colleagues here on what is data analytics. Can you hear us? Just give a shout out once you are able to hear us, Anagha. Very happy uh, to pass it back to you. So let me go to the next part. Whatever I said, whatever I said is here in the form of the simple pictorial which Anagha has put for you. We in Cipla use a
Yes,
tool called as, yeah, go ahead, Anagha. You can hear me?
yes. Thank you so much, Sharad.
No problem.
Yes. Am I audible?
You are, of course. Go ahead.
Yes. Yes. Thank you so much. Yes.
Anagha, I see that you again your voice has dropped off. So I'll keep going.
Yes. Yes. Thank you so much, Sharad.
Yeah,
Yeah. So as
I'm
yeah.
on slide
So
number
moving
6.
to
Keep going. Okay, so let me keep going till Anagha resumes. So we in Cipla, what do? We use a tool called MySetu. There are many such tools which capture the data for us. And I remember the previous part, what I said, it is about the analysis part. So this tool helps us in do analysis. There are many tools. Uh, uh, there are programs which make these tools intelligent. Uh, so there is Enablon, there is MySetu. Uh, there are many such companies which have come up that help in interpreting data for us specific to EHS. Okay, so in environment, health, and safety, uh, let me talk about environment part. Environment, health, and safety is no longer a function that is police, or we are in the environment part. We are no longer just looking at an effluent treatment plant side of the business and saying, oh, we have a lot of effluents coming in, let's reduce our water, let's have a program where we can reduce our water footprint. The world has evolved. The world has evolved tremendously in the last 10 years. And so, what has happened in the last decade is we think beyond water. Our footprint is on carbon dioxide or its equivalent, water, and waste. And when it will come to my own presentation, I will talk about it. And whenever Anagha, you feel you're comfortable, your network is stable, do come on, do unmute yourself, take that liberty to talk, and I'll keep quiet. Okay, I promise you that. So what we see is that
Yes,
go ahead, Anagha. You feel comfortable?
yes, yes, yes.
Go ahead.
So we were talking about environment. So yes, in environment data analytics, we are mostly focusing on energy, water, carbon dioxide, and waste. So this data we are getting on a monthly basis from each and every site. Then we are analyzing it, and then we are presenting it in a graphical or presentation form to the management. So and we are doing a comparison for each like each month basis, so we that where we can improve ourselves. Next part is health. So in health, we have OSC centers at each and every site of Cipla. So it is very important to focus on the health of each and every individual in Cipla. So how we are focusing that, that I can explain you in upcoming slides. Moving towards safety, there are incident risk assessment, lead indicators. So these are like factors which we are focusing. So in that case, we can give a secure and healthy working culture to each and every employee of Cipla. Next slide, please. Yes. So safety. Firstly, we'll talk about safety. Yes. So in that, I can show you two. Yes. Yeah. Please. Yeah. So two different sides, like, but right side we can you can see the risk assessment and lead indicators part, whereas at the left side you can see incidents and lag indicators. So risk assessment is nothing but like the word you might heard and are like while taking this MTech degree or while BTech, that HAZOP, ERA, hazard. It is nothing but the risk assessment techniques and hazardous operation. HAZOP means hazardous operations. So if we have any process which while doing tech transfer, or if any product which we want to do from a pilot or R&D level to pilot plant, then we are doing this processes. So these are nothing but we are minimizing the risk of incident or any hazardous, like any incident. So for that, while doing this HAZOP, HERA or hazard, we are giving a lead indicators, that is we are giving a control to minimize the risk. So there are the controls like elimination, substitution. Elimination is nothing but the removal of that risk. We are directly giving advice as a safety person that please don't include this, that it is hazardous for our process. Substitution is we are giving a substitution for that. engineering control is nothing but there is a control which we can engineering, like if any process is there, we can give an alternative for that, where we can arrange some engineering. PPEs are nothing but the personal protective equipment, like, and if any drug is there, while doing that, it might be hazardous to that operator who is handling that. So giving that PPE control is also a lead indicator, and administrative control also we are giving. So these are risk assessment. On the basis of risk assessment, we are giving lead indicators. uh, what if we are risk assessment is not effective? Now you will say how it is related to data management, data analytics. So data analytics is, as I said, it is related to environment, health, and safety. So this is about safety. So as my risk assessment will be effective, then there will be, like, if we see the left hand side of this table, then there will be a incident, there will be less incident. There are types of incidents. I will tell you. FA is nothing but the first aid injury. We are keeping our count that how many first aid injuries are there, how many medical treatment cases. LTI is nothing but the lost time incidents. Yeah, or fatality is there. So as we are keeping that, our incident rate will increase, there will be a lag indicators that is incident rate will increase, and that is nothing but the unsafe culture. So we are trying to focus on the risk assessment part, that is lead indicators part. So automatically the left hand side, that is incidents, and this incident rate will automatically decrease. So this is about the data analytics in a safety part. Next slide. So moving towards health, the second part of environment EHS is health. So we as a CIPLA, we have OHC center at each and every site of our unit, each and every site, and each and every unit as well. So there are OHC doctors are there, nurse are there 24/7. There are ambulance, and we are keeping a count that how many headaches are there, or skin irritation, or sprain are there. So on a monthly basis, we are keeping a count of that. So we can observe that, okay, at this time while doing this production or this, lots of people are feel irritation, or they may eye irritation or skin irritation. Then it is our responsibility to analyze that, oh, where it is, like, where we are lagging. So it is very important to focus on where we are lagging and to improve that self. So automatically our leading indicators, or our that graph will go up. So there, this is where we are focusing in a health part. Next slide. So yes, now moving towards environment part, that is energy, water, CO2 emission, and waste management. So I will firstly go on energy. As you all are aware, we are keeping a reaction in, like, in laboratory, and I will talk about, like, in a ICT, we are keeping a reaction in a oil bath. We are giving electric connection, and we are keeping it for like 1 day, 12 hours, 14 hours. So in a Cipla, we are doing products in a tons. In each unit, it will be in tons. So it is very important to keep a count, and how our energy is will be, we can reduce, and how reduce. I will say how I can use renewable energy. We can use renewable energy. So that part also we are focusing. Now, as I said that there will be units in kilowatt hours. There will be a second column, as we can see. So it is, as a data analytics, you have to analyze the data. The second, after collection, there will be analysis. So it is very important to have a, like, I am getting a electricity grid in kilowatt hours. So to calculate in a particular form and to represent in a proper way, I have to conversion. I have to do a conversion factor. So I am doing as a data analyst every month. I am doing whatever data I am getting every month from each site. The electricity which we use, the electricity from grid, IEX. Now we will see there are solar, wind, furnace oil, HSD, gas, briquettes. These are there. So out of that, we are differentiating. There is a renewable energy. So how much renewable energy was used like particular month by which side, that count also we are doing, and that is actual that in the sustainability point of data analytics. So here I am considering in renewable energy, um, renewable energy grid, electricity in solar, electricity wind and briquette. So this total will be a renewable energy. And other parts like we are using furnace oil, HSD, gas, briquette or grid electricity. This all we are using for boiler for utility purpose. So this all total energy, that count also we are keeping. So out of that, the renewable energy divided by total energy. So I have already converted this kilowatt hours into gigajoules. So it will be a presented form that there will be a number that I can show, like there will be a tons, and a tons number will be a very large. So I can show a particular number to management that okay, this much renewable percent energy we save, this much renewable percent energy we use for previous month. So next slide, I give an example. Next slide, yeah. So in this, if we can see that there is a electricity in grid which is available in kilowatt hours, so there is a conversion factor. So each and every parameter we converted into gigajoules. So if we will see the example as I showed, the renewable energy is total 9995 gigajoules, whereas the total energy is 18737 gigajoules. So out of that, we can calculate. First of all, this is not a CPLA numbers. This is just for a knowledge purpose. I'm taking this example. So the total percent energy is 53%. So as a like we can see for this calculation, we used to about 53% of the total out of total energy, 53% renewable energy we use. Yes. So moving toward next session, that is CO2 emission, which is one of the most important factor in sustainability we are focusing. And we are trying to use a renewable energy, so there will be a less CO2. Like this, in a previous slide, there are many electricity or the energy factors which are there. So out of that, like solar, wind, these are renewable energy. So we are not considering the CO2 emission from that. The if out of that, this electricity grid, furnace oil, electricity IEX, HSD. So these are energy from which there will be a CO2 emission. Same for this as well. We are using a conversion factor. So after that, we are receiving like that factors. After applying that, we are getting like how much tons of CO2 generated last month by this set, by that set, that also we are doing. So CO2 emission is nothing but the scope 1 plus scope 2. GHG, it is greenhouse gas emission. So scope 1 is nothing but the like we are receiving that CO2 emission is from fuels as well as from electricity. So this bifurcation also we are doing on our basis, that analysis also we are doing, that how much CO2 liberation from fuels and how much CO2 liberation from electricity, that where we have to work and where we have to give our best so we can minimize the CO2 emission, and we can do maximum use of renewable sources. And we at CIPLA, we are implementing solar panels as well as this wind, solar electricity at our site. So there will be a less CO2 emission, and along with a healthy life in terms of medication, we can also give a healthy environment as a responsible citizen. So we are doing that as well. So it is about CO2 emission. Next. So this is the example of CO2 emission. We are calculating CO2 emission in tons. So we are getting it in a kilowatt hours, like for electricity in grid, or for gas it is in gigajoules. So we are converting into a tons, and on a monthly basis we are giving a data to each and every site that how much tons of CO2 emission was there, and how much reduction is there, and we are focusing on that. Next slide. Yes. So CO2 intensity for different fuels. So I gave an example that emission in kg, like CO2 kilowatt hours how much, and gigajoules how much. So there is wood, peat, lignite, and different examples are there, that after that how much CO2 liberation will be there after by different fuels. So we can analyze, and we can use our like oils or our fuels according to this, and we can minimize our CO2 emission. Yeah. Next slide. So moving towards an environment, the last part is waste. So uh, as I said, that there is tons of production is there. So waste generation will be also is also there in a like that is also in a ton. So it is very important to uh, that whatever waste is generating, so we can minimize the waste, or we can give that hazardous waste to a secured authorized landfill. So as a CIPLA, we are contributing, means we are giving our hazardous waste for a authorized party, so they will decompose, or they will treat that waste, and there will not be any hazardous effect on the community as well as to environment. So that part also we are focusing, and in this way we are trying to minimize our hazardous waste, and we are trying to give us a clean and healthy life to each and every individual. Yeah, and that is from my end. Thank you so much, everyone.
Thank you, ma'am. It was indeed a very illuminating talk. And we would also like to thank Sharad sir for intervening when when we were facing some technical difficulties. Thank you, sir. Viewers are requested to submit their queries in the live chat option in YouTube. We are noting them down and we'll ask them by the end of today's session. So, moving on, I would now like to introduce our next speaker, Mr. Sharad Kalghatgi. Mr. Sharad has worked in chemical, pharmaceutical, oil and gas, and food businesses across Europe, USA, and Asia in manufacturing projects and corporate roles. During his career, he has been a chemical engineer at Research Center, process engineer in chemical manufacturing unit, operations engineer at refinery, economic evaluation engineer for capital projects, and HSE manager in global and regional roles. Mr. Sharad has successfully helped organizations achieve zero harm, 100% compliance, and has unique achievement of end-to-end carbon positive, water positive, and zero waste to landfill for entire group. He has served on board of Mondelez India. He has worked for BASF, SIBA, AstraZeneca, Shell, Mondelez Cadbury, and currently is Global VP and heads EHS and Sustainability for Cipla Group. Mr. Sharad holds a master's degree in petroleum and reservoir engineering and bachelor's degree in chemical engineering. He is also a visiting faculty at Texas A&M. Welcome, sir. For today's session, Mr. Sharad will be delivering a talk on trends and avenues influencing technology and action in sustainability. We are extremely elated to have his presence at IPGT. Mr. Sharad, you may now please begin with the talk.
First of all, thank you very much, students of ICT Green Technology and Professor Prakash Vaidya and to Pandit sir. It is really my honor and privilege to be amongst you all. What I'm doing is take this session not as a preaching session, but take this session as something that I have learned. And in the next 1 hour, I will try to download it for all of you. I have tried to keep it as simple. The intent behind this presentation is to give all of you, my young engineers, a flavor of what is happening in the industry outside and how you should see it. And if you can add on to the gems that you have picked up over the last few months, years, add on to it, and then we will make a better environment and a better planet for the future. So thank you very much. Let me just straight away deep dive into the next part of the slides. Anagha explained about sustainability, and I'm going to focus predominantly on sustainability. Uh, Personally, I see occupational health, safety, and environment as three equals through the same lens. I cannot, just like we say, people harm is not acceptable, or people injuries or health injuries are not acceptable. For me, equally, damaging the environment is absolutely no no. So let's look at the sustainability side of it, and what is it that we can think about, and how the future is looking for environment sustainability. When we talk about energy in the sustainability part, we usually look at heat transfer equipment. So what are the heat transfer equipments we have? We have a boiler, we have chillers, we have cooling towers, and we have many such fans, ancillary equipments that are there. Some run on electricity, some run on fuel, some run on various other energy sources. Yeah, but what we see is that the electrical energy component is a significant one. Okay, so in environment, we have the energy part. Then we have the carbon dioxide or its equivalent part. Anagha talked about emission scope, scope 1, scope 2, scope 3. If you have any questions on the type of scope, I'll be very happy to answer. Okay, but what these emissions tell is that some emissions occur because of me as Cipla, right, or me as an individual. And then there are some emissions which happen because I demand it, but I'm not directly responsible for those emissions. But indirectly, I'm definitely responsible for it as an individual also. And then in CO2, there are many tremendous types of technologies that we are hearing. Every industry I have been to and I have been working in, I hear them trying to provide a solution or have provided a solution. But in CO2, the history shows that the past 20, 30 years, it's been a test and learn kind of a thing, just like Tesla or just like any of the electrical vehicles that we see today. It's a test and learn concept that they have. Uh, and that's how technologies are evolving. You know, there are pros and cons in the test and learn, but definitely it's a great era to be in, to be honest with you. And I can have many hours of conversations on this. Then on the water side, uh, measuring water is important. And you'll say, Sharad, what are you saying? We all measure our water. Well, if you go to a plant and ask them, liter by liter, where does your water go? You will come to know what I'm saying. Or if you go to any building, we all stay in our hostels or in our residential buildings. Uh, just ask a question to the person who runs the water over there. What was it that you consumed yesterday, or the residential society consumed yesterday? He won't be able to give you an answer to the precision of a liter. And trust me, that's not a good space to be in. So I always say measuring is important. In water, our main source of water has been rivers, surface water bodies, that is rivers, lakes, ponds. We do rainwater harvesting, the dams, we all hear that. The key component is groundwater. And I will tell you all a very wonderful story. I'll ask a question, but I'll tell you all a very wonderful story about it if you ask me in the Q&A. Okay. And then water always has to be run with the 3 R's. Now, you will see I've deliberately not put recycle. I've deliberately not put recycle. Water is a very precious resource. The way we treat it after the use is extremely important. So the first thing is refrain, second thing is reduce, and the third part is reuse. Recycle part, everyone does it, so I'm not going to talk about it. That's the last part in the whole game. The challenge we put, and the challenge I put to everyone in the business, wherever I'm working for, I ask the question, why are you using water? Let me give you one example. Previous to this company, I used to work for Mondelez, which is famous for making Cadbury's, Oreos, Bonvitas, and things like that. So I asked, the first question I asked when I visited a plant is, how much water does the chocolate need? And the answer was 0. Chocolate doesn't need a drop of water. So the next question was, why do you have water in your factory? Right? And they said, we use it to clean, we use it for housekeeping and things around it. And do you measure that water? Yes, we do, but we cannot go to the liter level, dm cube level, but we do measure the water. And the next question I asked is, imagine I stopped water for you tomorrow. What would you do? You know what? Cadbury can survive without it. So that's where that challenge came, that 5 years from now, Mondelez factories should not use water. They should use water only where it is needed for human purposes. And the same challenge has been thrown at Cipla. So water, the first thing you should ask is refrain, reduce, and then reuse. Recycle is part of the reuse for me. Then in the waste, instead of refrain, it's refuse. And reduce, reuse. And in waste, we have put recycle, because in waste, there is a fundamental difference between reuse and recycle. Reuse means I can keep reusing it for the same activity. And the recycle is I can no longer use it for that activity. I have to switch it or make it into something different that I can use it and continue to recycle that way. And the fun word in waste is circularity. Everyone talks about circularity. There are very few who really understand it, and I'm not one of them. But circularity is a totally different concept. And if it truly becomes possible in waste, and it is possible, then we have a world, and our mindset will be very similar to Mother Earth. Mother Earth really shows us what is circularity. Every year when we see rains, that's part of circularity. And we have to, as human beings, understand that part. So I'll move to the next part, which is energy. Remember that the title that I gave to all of you is Technology and Action. In this world, technology can has its limitations. It can achieve only one part. The second part is the behavioral part. Our DNA has to change. The way we use things, the way we want things has to change. Okay, so it's a bit philosophical, but it is science, and that has to be extended to our people. And every conversation in Cipla, whether it is my peers, my managers, or whether it is my colleagues who are doing the hard work on the floor, my every conversation with that is, do you really need this much? That's the first thing we need to ask ourselves also today. We all are sitting in our nice places and listening to it. Maybe there may be about 20 or 30 of us who might be listening to this call. My request to all of you is, please think about what is excess around you. If you haven't used it, it's an excess. Same way for energy. If you have certain pieces of equipment and you can do without it, optimize it. It reduces a lot of footprints, including cost. Then the next part we need to ask is what we are using, how efficient are they? That question is very important. How efficient are they? And slowly, we should move to a modular approach. If I need steam from a boiler for a specific product, do I need to have one boiler for the whole factory or two boilers for the whole factory? If, as and when I need steam, can I have a modular boiler sitting closer to the process and supply the steam with minimum losses, transfer losses or other losses, efficiency losses, and a smaller boiler with a smaller footprint to suffice it? Those are the challenges we need to make with one another. And this is all behavioral. And the last bit is just like our elders taught us, if we left the electric light switch on and move to another room, they would come and discipline us. Our elders have always taught us to use things optimally. So it is equally important that we all, and as a collective enterprise, human race, whether it's you or whether it's me working in CIPLA or you studying in ICT, we need to collectively reduce the footprint. It's a team sport. Okay. On the technology side, we know that the world has cleaner fuels. In terms of fossil fuels, we know that we have a lot of crude oil, right? Technology is amazing. 30 years ago, we were saying crude oil is not enough. The world is going to end with it. The ads used to be around like that, where the earth is trying to squeeze the last bit of oil. That's the memory some of us have from 80s. But technology has evolved. And we know that there is abundant amount of oil. But we are having a different set of conversation today. We are not talking about whether we have oil. We are talking about whether we can switch from oil. So the cleaner technology is the gas tech. All of us are engineers and we know why gas is cleaner. Then there are renewable fuels for boilers, for example, briquettes, something that keeps coming and we can use it as a part of the ecosystem and keep going. And the technology side is evolving tremendously to generate the energy. We all know the law, right? Energy can be neither created nor destroyed, but it can be converted from one form to another. Man has really started using this very well on the renewable energy side. So what we see is the solar efficiencies are shooting up. There is a lot of research going on. Wind also, there is a lot of pickup on kind of materiality we can use for our wind turbines to make it more efficient. We have tidal. Very soon we are hearing that cars can generate electricity when they are in motion. So the EVs, and then technology keeps evolving. Mankind is such that we cannot sit in one place. We need to keep moving. The next part which I want to talk about is carbon dioxide. And here predominantly I want to focus on clean tech. In terms of fuel, a clean tech is a solid is the least efficient fuel. Gas is the most efficient fuel. How do we make it out? Just go and look at the chimney or look in our house as we have evolved as human beings. When our grandmothers, I don't know about you all, but my grandmother, when she used to cook on the wooden stove, it used to be smoke everywhere. And then we had kerosene, gas stoves. We call it gas stove, but it was kerosene that was put in the stoves. It had soot. So the first two fuels had soot. But today, when we cook on a gas, we hardly see any soot. That means the carbon is burning very well, efficiently. So moving to cleaner fuels. When we talk about renewability has a very strange definition. And somewhere in the mankind, we have forgotten what is renewable. Even fossil is renewable. It's just that the turnaround time for a fossil fuel to become a fuel is longer. So that recyclability doesn't exist very fast. The time frame that we as mankind, who have just arrived in the last few minutes on this earth, are not happy. So we want everything fast, quick, right? Fast food. So fast fuel also. But we know the fossil has its issues. So that's why we are looking. So mankind, what did they do? What we have done? We moved to plant-based fuels. We heard Brazil has alcohol, ethanol that they use for burning uh, uh, fuel in the car, right? So they moved to plant-based, which is predominantly ethanol comes from sugarcane. Then we moved to an algae because we thought that algae biofuels are better. And then we are now moving to natural energy. That natural energies, as I talked about in the previous slide, the sun, the wind, the water, geothermal. So there are many natural energies that are available. We are trying to source that. So that's how the renewability part is moving. In all of this, everyone asks, and one of the prime reasons why electrical vehicles are not yet mainstream, but we know they'll become mainstream. And we can talk about it as we go further. Uh, Return on investment should be there. I should not be spending disproportionate amount of money just because I want to be environment friendly, right? All of us want to be environment friendly, but if you ask me, would you take that sacrifice, Sharad, to go to your office on a cycle? I would say yes, if it's 5 kilometers. Yes, if it's 10 kilometers. But moment it becomes 30 kilometers, I'll start sweating, even if I'm not on the cycle. So, so it's all about doing that balance, right? So return on investment is very important, and I'll come back to you all when I'll speak further about it in the coming slides of how this thing is turning around. We spoke about energy, we spoke about carbon dioxide, yeah, previous slide. Now we'll talk about water, and we'll talk India centric. I stayed 18 years in United States uh, out of my 2.5 decades of experience. But let's talk about India because this is where the fun is. Uh, Three maps in front of you, everyone. First map is the natural vegetation map that we have as of today. That means the trees, the grasses, the shrubs that we see in India. What do you see? You see that India is a mix of trees and not enough trees. Okay. Strangely, when you overlap that with a river, so imagine you're overlapping the map in the middle with the map on the left. What you would see is that, and don't get deceived by the green color. The green color here is bad. Okay, it's hot. There is not enough vegetation. And what you would see is that where there are no rivers, the vegetation takes a hit. Sharad, we know this. Why are you telling us this? Good. Thank you. Then the third map is population. Now, superimpose all three things on one another. On one side, you need a river source to keep your natural vegetation going. But there are 1.3 billion people who need their water every day. So something going to natural vegetation gets diverted to mankind. What is the outcome? The outcome is on the right hand side map that I'm showing to all of you. In the 1980s, if you want to interpret this map, look at the top part. The top part of the map on the right hand side shows the forests. What you see is in 1880, 140 years ago, we had a lot of green forests, we had very little cropland, farmland, because man needs to use that water not only to drink. So if you misinterpreted that mankind needs it, mankind doesn't need water just to drink or have a bath, but they need it to make their food also, to get their food. What you see is in 1880, India agriculture was fairly balanced. What you see today is 1.3 billion mouths to be filled. And in that, there is a lot of inefficiencies. People say that 67% of our food gets wasted. I might be wrong. It might be 50% also. I'll be very happy to hear that. But that means 50% of what we generate is wasted. That means that water, everything, right? So the intensity by 2010 was huge. Same way, you look at the forest. You will say, Sharad, forest looks fairly the same. What are you trying to say? No, it is not the same. You see, if you are, they say man can read or look at limited amount of colors. A woman or a girl can see more color shades. What you would see is that our forests have become less denser and in some places they have disappeared if you look at it very minutely. So water is a very precious resource. Somewhere to fill our stomachs, we are compromising on our natural vegetation. And please, by the way, these are not political maps. Huh? So if you see a half-cut Kashmir, don't come at me. It's just that what I have got from the international studies. We will go and address it with them. Please don't address it with Sharad. But my intent is that mankind, we need to do something about it. So let's talk about the solution part of it. Everyone talks about the problem statement. Let's now focus on the solution part of it. The main thing that we need to do is we need to replenish water. Why? We are blessed with one thing, which most of the world tries to grapple with. We are blessed with just the right amount of rains that we should get per year. We have, we always envy that other places, they have more seasons than us. There is a fall and there is a spring. Well, there is a fundamental reason behind it. We'll not get into that. But what we have is a very clear-cut season where we get water in one season. That water doesn't evaporate in the next season. We call it winter. And then the following season, that water evaporates because the same water has to come back to us in the next season. So we have a right amount of water that we receive. But what has turned into the imbalance is that we are consuming too much of water, so we don't allow this cycle to happen properly. And it is very important that we replenish what water we get. Usually what you would hear if you go into the industry, people will say, make rainwater harvesting systems. So what is a rainwater harvesting system? All the terrace water gets collected into a tank. And after a few rains, that tank is full. We allow the rest of the water to drain. Why do that? Our most natural rainwater harvesting tank lies in the soil below. Water reservoirs. Now, what we imagine is this water reservoir is not like a lake or a water that is floating below us and then we need to fill it. No. There is a layer of sand. This layer of sand can be as thick. I use the word thick, can be as thick as 1 feet to a few hundred feet or thousands of feet. In these layers of sand, which is spread across hundreds and lakhs of square kilometers, depending on which area are we in, hundreds or thousands or lakhs of square kilometers, is spread across. And let me use two engineering terms. Most of the places, it has good porosity and good permeability. Porosity is because it's sand, like a sponge, it can absorb everything very well. And permeability is it can act like a pipe. That means water can flow through that channel very easily, just like a pipe with minimum hindrances. Yeah, very crude definitions, but I just let you all know for the understanding of it in case. This layer of sand has good porosity and permeability for most part of it. And it can absorb millions and billions of liters of water. So if you next time you go to a factory or you go to a village and people say that this borewell is dry, you should congratulate those villagers because You have the most natural rainwater harvesting system that you can make. All you need to do is you need to ask them, remove that borewell cap, allow all your rainwater to go through it after filtering, fill it for the next 3 to 5 years, and after 5 years, put the borewell back in, start pumping water. For the next 25 years, you have uninterrupted water for your next generation and for your generation. That is replenishment. That is real rainwater harvesting. If we cannot do that, build a check dam. If the check dam cannot be built, do the ponds. Ponds, our ancestors, whether it is during the great Mughal times or even during some of our Aryan period times, you can see that uh, ponds were a very good supply of water. We can make reservoirs. The most common man-made reservoir is a dam, but remember, it's built on a river. You can make other reservoirs as well. And the third part is, the last part is the civil tanks that we all talked about earlier. I spoke about earlier. But in this, what you will see is, moment you replenish that water, your flora and fauna also because of this underground water changes tremendously. It has a lasting effect. Things come back. Nature is at its best. Then the next part is refrain, reduce, reuse. And if you as future professionals who will go and work either on your own or you will consult or you will work in an industry, and if you see an ETP, remember this golden thing that I'll say. Never allow water to enter a ETP. ETP should be the last resting place, just like we say Smashan is the last resting place, right? Same way, ETP should be the last resting place for water. If someone is putting that water in the ETP, make infinite recycle loops. Treat it, take it back. Treat it, take it back. Don't allow that water to go there. Because in ETP, we treat the water and we evaporate, or we use it for insignificant purposes like gardening. That's a very insignificant purpose. Garden just makes you look good. That's it. You will feel it goes into the ground, underground. No, it evaporates. Because reservoirs are not so above. Reservoirs are all the way down. The tree roots can go up to it in some cases. Now we'll talk about waste. Okay. We as human beings have misunderstood the word waste. And particularly in the last 5-6 years, we have put a binocular on our eyes, and we have put a filter on our ears, knowingly or unknowingly. Let me talk about it later. But first, you leave anything on this earth, the earth will recycle it, and it will never say it's a waste. It will use it in some form or the other. Plastic, as we know it, the earth will take time to chew it up, but it will definitely chew it up. We as human beings have said, it takes 1,000 years. For earth, 1,000 years is nothing. It has survived for 4 billion years. 1,000 years is just a speck of sand for it. So it has its own recycling system, but nothing is waste. Each time the earth upcycles it, and it knows how to do it. So if we today spoil its flora and fauna, it will reinvent itself, where it will stay in us, where it will have things, where it will not use the same old flora and fauna, but it will keep recycling, upscaling. It will keep doing it. We don't need earth. Earth doesn't need us. We need the earth, because we as human beings, remember the Matrix dialogue, those of who have seen the Matrix, we are a virus, right? We keep consuming. It's very harsh on us, but that's the truth, right? We keep consuming. And we feel that we are the most flexible being on this earth. But trust me, we are not. Moment something changes in our temperature cycles, that too by just 2 degrees Celsius, we start flipping around. And we are creating a world protocol, sustainable development goals, right? The part that I showed you in the beginning of this slide. That is what is happening. So the earth doesn't need a definition of a waste. There is nothing waste on earth. But from a mankind perspective, we have a lot of waste that we can look at. And this is the lens through we look at it. Now look at it and see how much of plastic is there in 60 to 70% of the world. Just 12.4%. But look at the amount of noise we make. Plastic is bad. Well, as human beings, let's accept it that we invented plastic. Number one. Number two, plastic is not bad. It's the way we treat it after the use is bad. Okay. So that is where we need to focus. Plastic is not bad. It's the way we treat it is bad. Number two, waste, what we say is waste, has tremendous value in many ways. Some waste give you energy. We know the biogases and some of the cement incinerations that they burn, this multi-layered plastics, the polymer forms of plastic, all the industrial waste, which has high in calorific value, that gives energy. But of course, it has its own set of emissions. Then the second thing that people are doing is they try to make value out of waste. If it's a rare metal or if it's a paper, we all know, we all do it, right? All our families have done it in the past. We sell paper. We sell paper at 4 rupees, 5 rupees. Some of us stack it to get a better value during rainy season. We all do all that. So that is there. And then we have efficiency is part of it as well in the waste, where today we are saying, let's use less plastic. Let's use that cloth bag to go and do the shopping. Let's use paper bag, or let's not use paper. Let's substitute paper with something like a electronic device, things like that. And then we have the regenerate part where, we make compost. We try to upcycle it. I always call composting as upcycling because it's a tremendous gold that we have as mankind. So that's the waste. Let's speak about plastic a bit. What we are telling and the decibel noise we are making is utter nonsense. And I'll tell you why. In plastic, technologies have moved, whether it's single layered or multi-layered, for pellets. Now these can be converted into pellets. There is oil so it can be moved back to the crude oil. It can be put into the furniture. The only thing is, what we need to come and define as a problem statement and solve for mankind is the food grade plastic, because there it's virgin plastic that needs to be used. So there is no upcycling of that plastic that will ever occur. It will be always downcycle or part of the recycle. The second part is we need to strengthen our reverse supply chain. That means just like a product can go all the way till the last grocery shop, similarly, plastic also has to find its way back to the source of company that can recycle it. Just like paper, newspapers, they have done that, established it. We just need to think about it like that. And we need to make sure that hand in hand with government, hand in hand with regulators. Yeah, not shrugging ourselves off. If we are the source, we are the source. We need to have a problem solution to it. And there has to be a value proposition. As I said, papers are recycled, right? So the way they do it is people get money for it. So if people are educated and if they can get money for it, why will not there be a value for it? We'll store it, we'll give it back. And India is terrific in that. We are great in that. And then the other part is lack of civic awareness. We are trying to focus on that, right? Swachh Bharat Abhiyan. And I'm not a proponent of government or anything. Huh? I'm just saying that Swachh Bharat has happened now. It should have happened 70, 80 years ago, if not beyond that. It's just that we have to become more civic. That's the key part. Yeah. Sharad, you have spoken so many things. Uh, Talk about your CIPLA or talk about industry. So this is the slide where I'll talk about CIPLA. You know what? Today, we are in a great era. In this era, I, sitting as the environment health safety professional in an organization, can save money for the organization. And that's where I'm sitting, and I'm in the cockpit. I am helping drive save costs for the organization. So there is a cost of energy, there is a cost of water treatment, and there is a cost of handling and disposal of waste. But what we have done is we have flipped it around. How? Sharad, you have shown me this slide. The top part I already know. Yes, you know the top part, but what is interesting is the bottom part. Biofuels conservatively cost 15% less than the conventional high speed diesel. Game on. So all my diesel generators are switching to biodiesel because I've saved 15% of the cost. And guess what? It's from coming from renewable source. I've upped the game. The next part is the renewable energy that I'm getting is either at par with what my state electricity boards are giving to the factories at very few places, but at most of the places, they are giving it at a very low rate. And here also I've put conservatively between 10 to 18%. Next switch has occurred where all my plants are switching to renewable energy. I just have to pay some minimum amount. I have to just pay some minimum amount and draw some minimum amount of energy, which can be 20%, 15%, 30% based on the agreement and contract with that distribution company, state distribution company, and the rest all I can switch to renewable energy. Not only does my fuel become clean or my energy source become clean, but I save crores and millions of dollars for the company just by this one switch. And the third thing that is occurring is, which I have not put here, but definitely I can tell you, all my boilers, 50% of my boiler footprint is disappearing, not just because of efficiencies, but because of the technology that has moved. Some of my boilers will be solar. And I'm not exaggerating. We have solar technologies that has been implemented at my previous organization. The same will occur in every industry. Solar is the name game. And you can ask the question, Sharad, what happens at night? Well, during the day, I don't just have to heat water. I can heat an oil. I can heat a metal plate, keep it like a thermos flask, tight lidded. And whenever I need a warm water or a steam, I can use it at night. So my solar footprint in terms of boiler will jack up. And that's the way things are moving. And all these technologies are not intensive, where I'll need a moving piece of equipment, where I'll need something to fire, ignition, provide ignition when I say fire in terms of boiler. I don't need all that. So all my costs, and no fuel costs, by the way, 50% of the fuel cost goes away. So my cost of keeping a technology and running with it, OPEX comes down significantly, CAPEX comes down significantly. So my return on investment looks tremendously good. Yeah, and this is the language I speak with my finance people. So the last few parts is my return on investment on energy. Now, as of today, stands at 1 to 3 years. That means if I invest in my energy project, within 12 months to 36 months, my money is back. So my finance colleague, partner, is tremendously happy because he says, Sharad, I don't have to go and expend for the energy for the lifetime. You have just within 12 months, you have given me a source of energy that is indispensable. Waste return on investment. Again, waste technologies. We are using a lot of solar. The technologies are amazing in waste. It's amazing. So the return on investment is 2 to 3 years, where the waste that we generate need not always go out. Hardly 4 or 5% of it can go out, which we can send to the incineration. The rest, all of it can get recycled and upcycled, and we can reuse it back. So something that comes into our system, never leaves our system. The return on investment is 2 to 3 years. Now, water, as I said, it will take me about 5 to 9 years if I do any water project. We believe in zero liquid discharge. We believe in the water replenishment. We believe that we can create an uninterrupted source of water for all our plants, and that's what we are investing in, so that we are making any organization, not just Cipla, professionals like me, can make our organizations risk proof, risk averse. And all of these investments helps us have tremendous amount of reductions along with efficiencies. So my renewable energy sources will become about 90% in the next 5 years. The rest 10%, I just need to go out and plant trees and equate whatever carbon dioxide equivalent emissions I'm making by planting those trees, because trees are the most natural and best form of sequestration. Then I don't have to depend on water. None of Cipla's factories in a decade from now max will need water from outside, and 100% waste recyclability, proper waste recyclability in 3 to 5 years. So we have pulled the bazooka out, and we have an aspiration. So when a Google and a Microsoft say that in 30 to 40 years, they'll become carbon neutral, as the only second person on this planet who has made the entire organization carbon positive, water positive, and zero waste to landfill, all three of them together, we are ready for the next challenge. And we won't need so many years. We'll borrow a few years from you, because you are our future generation. And Cipla will give back to you the world that it uses in a better way than what you have received. I mean, what we have received it. So the outcome of that will be that organizations, this is not just Cipla, if we put our mind to matter, in 5 years, an entire org can become what I'm showing here: carbon positive, water positive, zero waste to landfill. That's all I had. I hope this session was helpful for you as an academic, as a student. And if you have any learnings to share with me, please do share it with me. It will be my pleasure to take it into my fold. Thank you.
Thank you, sir. It was indeed a very scintillating talk, and your talk has certainly changed our cliched opinions on certain topics. And we hope the future is more sustainable and greener with our collective efforts. Thank you, sir. And with this, I think we may now begin the question and answer session. I request the participants to kindly ask relevant questions in the comment section of the YouTube, which will be passed on to the speaker by our team. We have a few questions. Firstly, questions for Ms. Anagha.
Yes.
Yes, ma'am. So there is a question from Mr.
Excuse me, madam. Sir, would you stop sharing the slide? I will be immediately sharing the questions on the slide.
Okay, I've stopped sharing, so you can go ahead now.
Thank you, sir. Yes, ma'am. So the first question is from Shushil Chavan. He has asked when exactly we use hazard at which state of the process development.
First of all, thank you, Sushil. So, hazard is nothing but the hazardous identification. So, we at Cipla, we are giving trainings on hazard. So, it is not only restricted to any process. It is we what we observe, what hazardous situation or what hazardous thing we observe in a plant, that thing we are focusing on. So for any process or any tech transfer, we are doing HAZOP. For hazard is for the identification, and it is not only restricted to EHS department. It is like for entire the organization, so they can identify and
Excuse me, ma'am. Sorry to interrupt, but your voice is breaking.
incident will decrease. So it is related to that. Sharad, if you want to add something.
Anaga, I know that there is an internet issue at your place, or network issue. We heard you, but I'll just summarize it. So, hazard is just one part of the overall risk assessment process. It is identification, right? Unless you identify the hazard, that's what Anaga was trying to say. You cannot assess the risk. What is the quantity of risk, and is it acceptable or unacceptable? And then accordingly, you do a comprehensive barrier check. And as Anagha said, right, elimination, substitution, the hierarchy of controls, we move into that: engineering control, administrative, PPs. So that's the way. So what we try to do is we try to make the process intrinsically safer, and hazard is one part of the risk assessment. There is HAZOP, there is hazards. These are all tools. End of the day, it's also equally important how well and deep dive you do in your risk assessments. Hope I answered, I added and uh, built on your points, Anaga.
Yes, thank you, Sharad.
Yeah.
Thank you, ma'am. Thank you, sir.
Next is
Yes, ma'am. Yes, ma'am. Please, please.
next is Priyanka. She is asking that can you share your interpretation on data analysis? So in last few slides that I shared, like energy, CO2 waste. So that was the like analysis I'm doing in the like sustainability part, where we can like if anything is like for energy kilowatt hours, so I'm converting it into gigajoules. I also gave a reference factor from where we are getting this conversion factors. So after converging like CO2 in tons, so like the conversion factors for how we are getting it from fuels and from electricity, that I represented in a presentation. So I think this question was asked before I presented. So it was there in the presentation, Priyanka. Thank you so much.
Thank you, ma'am. Next are, sir, we have a few questions for you, sir. Nitish, can you please change the... Yes, sir. Sir, so we have a question. How do you think the idea of green technology can be incorporated and encouraged amongst companies and industries?
So I've already shown that, right? When I spoke
Yes.
about energy, carbon dioxide, water, and waste, all these are doable. and are being done and can be done and have been done. And that's where we all are collectively moving towards to achieve the sustainable development goals and also our our endeavors. Right? I've
Right.
explained it, I think, elaborately,
Yes,
but I
sir.
can be even more elaborate if need be. Okay.
Yes, sir. Thank you, sir. Um, the next question is, how can we balance sustainability with economic viability? What are some of the factors that stops companies from adopting sustainable alternatives? And why are sustainable technological advances limited?
Yeah. So the advances are not limited. That's a very good question. I think it's asked by Priyanka.
Priyanka,
Priyanka,
yes.
the advantages are not limited. There are tremendous advantages, as I showed to you. We can, in fact, we have a good return on investment. The problem lies in any company or any entity to go out there, find out what is the best fit technology for their given business and implement it. That is the need. Technologies are there, they are evolving, and they will continue to evolve. Just like a new car every few years gets evolved, a new phone every year gets evolved. So, same way, technologies will keep evolving. The intent should be for the people in these organizations to venture out, to partner, to see what is there, come back and say, hey, I found out this technology which is doable. It has a proof of concept and it has a demonstrated proof of concept. Someone has used it and they have checked it, they can verify it for us to say that this technology indeed saves not only money but is good on the environment and can be done. That agility to learn, that intent to transform is the key for the organizations. And the fact is, organizations today don't have time. They are against the clock. If they don't evolve, everything else around them will evolve and they will perish. That's the truth, whether we like it or not. Because that's where everyone is sitting and taking a focus. What is it you as a company are doing to take care of your people, caring for life, to take care of your products, to make it the right way, to take care of the planet, to give it back and to not harm it. So that's a given. People will be asking that. And in the social media world, it is very easy to spread such news if there is any fallout. The key part here in this is how keen the organizations will be to focus it. And all it needs is just one person in the organization to just stand up and say, by the way, I look at this and I can tell you that we can save X amount of money on this straight away. And everyone in the org will take a look at it and notice it and they will ask the question, how? And that's where you get the entry. Right?
Yes, sir.
So it's all about getting the entry, making that first move. Sustainable technologies today are cheaper and easily available. Let me tell you that. And we are in an era where very soon we will see all this happening in right in front. It is happening. It's just that it is not directly happening in front of us. Yeah.
Thank you, sir. Um, yes, sir. So, thank you so much, sir, and thank you so much, ma'am. With this, we can close our question and answer session. And that concludes our session. And I take immense pleasure in thanking our eminent speakers, Mr. Sharad Kalghatgi and Ms. Anagha Barde, for such an informative talk and for contributing their valuable time. I would also like to thank our Professor Prakash D. Vaidya sir for supporting and guiding us throughout the events. I also thank all the participants who connected with us today and for being a very delightful audience. Lastly, I would like to thank the backend team IPGT for managing the program. And for any queries, you can please write us at the mail ID shared on the screen. And thank you and have an amazing day ahead.
Thank you, everyone.
Thank you, sir. Thank you, sir.
Thank you.
Thank you for the
Thank you, ma'am.
opportunity. Bye-bye.